Merci. Merci. Thank you, Jesus. Thank you. Welcome. Well, welcome to you. I'm really happy to be here in Vigo. This is the first time in my life. And it's something like I was dreaming of, a long time ago. And so I'm really happy. And so it's, even if we are a small committee, I'm a bit impressed. And so I'm working at Ifremer in Corsica, a small island in the south of France. And I was in Nantes some years ago, and also Ricardo was working with us at that time. And it started a long, very good career and on ecotoxicology. And then we switched to marinitor. So I will try to give some explanation about, I will try to make it very informal so that, the people are really relaxed and can ask during the talk if you want some more explanation. Don't hesitate for that, please. So usually the sea is something, the feeling about the sea is something like we consider it as exotic, or there is something, traveling, islands somewhere, blues, lagoons, and this kind of things. Sometimes power, large waves, and so on. And besides, there are some economic activities. Fishing, for instance, aquaculture, transportation, and so on. And the problem is that beside the sea, we do have the land, and from the land are coming a lot of pollution. So the most some are well understood actually, such as oil pollution and so on. You did have some bad experiments there in Vigo, and also metal contamination and so on, radioisotope and so on. And an emerging field is dedicated to marinitor that was starting, in fact, a long time ago, but just from a small community, just some scientists who are considering this problem. And it seems that because of DG Environment, European Commission, considered that as a main problem in 2008 when it launched the European Directive, MSFD, Marine Strategy Framework Directive. It has become something like very important. At the same level, actually, in terms of policies and management, at the same level than biodiversity or chemical contamination, eutrophication, and so on. So in terms of policies, it's very important. And also in terms of social problem, it is a really important social problem. And so the politicians are following this topic, and it seems that they will take some reduction measures very soon. So the point with marine litter is that it's about 4 million tons of garbage every year in the world. So for Europe only, it's half ton every year from each individuals. The total amount of plastics is around 290 million tons every year, actually, and is increasing regularly. So it's a lot of plastics that are being crafted, and it's about 6 million tons. This comes from the National Academy of Science. 6 million tons of debris from ships every year that are discarded. And we evaluated the concentration of microparticles that are coming from the degradation of plastics to more than 100,000 in the Mediterranean Sea. And the Mediterranean Sea is one of the most affected in the world in terms of plastics and microplastics. So marine litter is very diverse. It's a lot of types of debris. You can see from, plastic is the main important, caps, lids, and so on, but also bottles and so on. But any kind of debris, you will find them. We do have a lot of stories, strange stories. Wonderbra found them in trousers and so on, cars, planes found in the bottom of the sea and so on. But what we have to retain to know is that plastic is the most important part of these debris. Actually, we are trying to consider sources. It's quite complicated to understand exactly where they are coming from. The point with plastic debris is that the sources are really diffuse. So we know that some are coming from rivers. So this is the Seine River in France. And you can see on the side, the litters are accumulating. And this was a count of, they are used clean ears. It accounts for just only 100 meters along the Seine River. So if you look precisely, just, take the stones out and collect, and then you will find plenty of, and it's really a huge problem. So sources are also, sometimes they are coming from marine activities. This is an example that comes from a European project, Lost Cons. And these are the containers that were lost, in the Bay of Biscay. Okay. All the containers that were lost in the Bay of Biscay, and you can see that because of the traffic lanes here and the entrance of the channels, this is, most often where the ships are losing their containers. It has been considered it's about 10,000 containers lost in the world every year. And one container is 20 tons. So it's really important because if you consider microplastics, for instance, the total amount will be something like 30,000 tons at the surface of the sea. If you consider containers, for instance, in terms of quantity, it could be more than any GI or conventional zones in the ocean and so on. So lost containers is a very important source. Then you have some discharge. This one is in the Mediterranean, in Lebanon, and it's directly by the sea. And the bulldozers are coming and just pushing all the debris at the sea. And then the debris are starting to circulate from Lebanon to Syria, Turkey, Greece, and so on, and then to other countries. And they're just pushing the litter at sea directly, you know. They don't care about, you know. And so this is an example of lost containers, and these are what we call mermaid tears. It means pellets made of plastic. You know, if you want to give a form, a shape to plastic, you have to warm. But if you want to warm a large piece of plastics, it will cost a lot of energy. And so instead of having transportation of large pieces of plastic, they are transporting in just small pellets. It's more easy to warm them and to shape them. And this is the reason industry is just using pellets. And sometimes they're losing some. There were some accidents in Hong Kong 3 years ago, for instance, and regularly on beach you can find this kind of small pellets. These are colored, but most often they are white. And the name is mermaid tears. It's a very nice name. Mermaid tears, it was a name given to small pieces of glass in Greece long time ago, you know, and it has become just pieces of plastics, actually. Then maritime activities, aquaculture and so on, especially in Vigo, for instance, is a source. Some countries are really affected. Korea, we went together in Korea 2 weeks ago, and they do have a really big problem with polystyrene coming from aquaculture. Also Chile, southern Chile, because of cultivation of salmon and so on. So these could be very important source of marine litter too. Tourism also is quite important in terms of inputs. It could be the main part of litter on the beaches in some areas, especially, for instance, in the Mediterranean. And so, more or less, we know now that it's about 80% of debris litter is coming from land, except in some areas, for instance, southern North Sea, because of traffic. It has been inverted, so it's 80% is coming from marine activities at sea, traffic mainly. So most of the time, it's just coming from the land with diffuse sources, and we don't know exactly at the moment where they are going. So this is really a problem. So then after, what will be the fate of plastics? So sometimes it could be 100% for floating debris, for instance, but most of them will go on beaches. This is an example in Libya. We had a cruise in 2009, before the war, and we found some beaches with really lots of plastics accumulating. This is in the northern part of France, Atlantic, and this is a specific problem in some areas, Mediterranean, but also in some other countries, of cigarette butts. And we were told that by English scientists, MCS, they will come tomorrow at the meeting there, that because there were some restriction on smoking, you know, it's forbidden in public areas and so on to smoke. And in some offices, the people are used to go outside the buildings and offices and just smoke outside. And then they are throwing away, the butts away. And then because of the rain and so on, it comes to the wild and sometimes to the sea. And just because of that, because of restrictions in the last 3 years, the number of butts have been increased by more than 20% in Ireland, for instance, in beaches. So you can see in terms of health, it's quite interesting to restrict the use, but in terms of environment, it could be, adverse effect. So litter may also float. So this is an example count by an NGO in the Mediterranean Sea, where actually we are working. And so what is interesting there is that we can see that we found them exactly in the main residual currents. That the name is Liguro-Provençal currents, and this is where they're accumulating. So we are beginning to understand how the litter are moving at the surface of the sea. And in fact, hydrodynamics is the main driver at sea. This is the main point that is, providing information where they will accumulate and so on. So I will come back to this later, but so actually the scientists, they are trying to put together some experiments and just to have a general view of the quantities and so on. For floating, we are in the range of normally it's about 1 to 2 per kilometer square. But we do have actually some new methods such as this is on beach. So this is 1 to 2 kilometers square. We do have also a lot of data coming from, Atlantic part and so on, just to give an example. Okay, and then the point is that litter may accumulate on the seafloor. After they have been, at sea, they can sink to the bottom, and in some place they are really accumulating. This image is 10 minutes trawling south of Marseille. 10 minutes only. You put the trawl, it was not so wide, it was just 13 meters, and 10 minutes after, this is what we collected. And in many areas, that could be the same. I'm not sure you did trawl, for instance, in the Rayas there, but you can find some places where they're accumulating too. And this was 450 meters, and it was offshore Porquerolles in the south of the Côte d'Azur, for instance. This is the examples of the river. For years, the people were thinking that all the litter were coming from Spain in France. They were saying that, we say from Spain. And the Spanish were explaining that, the French, they are coming to Spain, they are buying things, and then they are throwing the litter on the beaches, but they are not coming really from Spain. And so we did have an experiment. It was in '98, and we found, the river Adour was of the main driver, flushing directly to the area there. And the point is that Basque Country is very special areas because in winter it receives the current from the Portugal currents and along the coast. And then in summer it is inverted and they are receiving from the Bay of Biscay, French part of the Bay of Biscay. So in any case, the Basque Country is receiving. So there is a very special situation where they are really accumulating, and in fact it's just only a few % that are coming from Spain. Most of them are coming from the land. So this is how an experiment at sea, counting on the seafloor, may explain a situation. That's very interesting. So we have been very far. It was in 2003 on an icebreaker. We went to 80 north, more northern than Spitzberg, with a German icebreaker. And we have been counting there. This is the Molloy Deep. This is a special area, 5,500 meters. And we found plenty of different litter. And the densities here were exactly the same than in the channel between England and France. So channel is a very specific situation because the flow coming from the Gulf Stream is entering the North Sea, so the flow is very important. So it's not so much in the channel when compared to other European areas, but there are some. And if you go far north, you may find, a very large amounts of debris in the same range in terms of quantities. And what was interesting, this is not very clear, the image, because it was very deep, but it was a net from trawlers. And there is no trawlers there, and the first fishing boats are in Reykjavik, and they are 2,000 kilometers from there, So it means that these have been transported for a long distance on the bottom. In fact, what they are thinking, they are lighter than outside of the sea, and so they may be transported very far. And so actually, you probably heard about conversion zones, the areas where the litters are accumulating at the surface, what they call gyres and so on. We think that probably there are many areas in the world on the seafloor where the litter may accumulate. So that will be one of the challenges for the specialists to find new areas where they are really accumulating on the deep. And this is very important because we know that in this is a minor part of the debris that is floating at the surface or beach, and most of the debris are in fact on the bottom. Okay, so we do have also some data about on the seafloor and so on. So I will provide some explanation about the area around here. So this is the case. We had some experiments, for instance, the seafloor in the North Sea. It was some years ago. In the Bay of Biscay, and we have some, for instance, where the sediments, fine sediments are falling on the bottom. We have also the litter that are falling. This is the percentage of fishing gears. And you can see, for instance, that south of Brittany, a lot of debris are coming from fishing activities. So it's a very important thing also. If you have a lot of fishermen, you may have a lot of fishing debris coming from fishing. Because the fishermen, they are source of litter and they are affected by litter, both, And these are data coming from dives with submersibles. Our institution, Ifremer, is owning some very deep submersible. We're able to dive 6,000 meters. And we did have some dives, and we analyzed all the dives there. It was done in the 2000s. And we found that in the canyons, this is where the litter are accumulating. So I will provide some images later. But I mean, it's quite clear that the shelves are cleaned because of the currents and so on. And then they are falling to the bottom through the canyons, and then they will settle there. So this is another example in the channel. So we have the Seine River that is cleaning the area because of the flow, but on the side they are accumulating because the inputs are quite important. It was in 1998, and you can see this is on the ferry line between Brighton and Dieppe. And these debris were made of glass. The people throwing glass from the ships, ferries. And we did have the same situation in Corsica, between Italy or France and Corsica. All along the shipping line, it was a lot of glass debris, because they are falling and people. But then it has been switched. Actually, they are using plastic bags, and we are starting to find plastic cups. For instance, in Corsica, we do have a company. This is Corsica Ferries, and the color is yellow. The ships are yellow, and the plastic glasses are yellows also. And when trawling, we are beginning to find this kind of. So we know exactly where they are coming from. It's not the company that is responsible for this. The people passengers. But we start so you can see, for instance, along the fishing lines. And then we have areas where turbulence of the water is very low, and also then the litter will settle. And you can see that in 12 years, we have more debris, but always at the same location. It's quite interesting, It's big, even in 12 years, when you go the following year and you do an experiment again, you will find exactly the same distribution. So we have the trends. We can check how it has been changed. And if I go to Mediterranean Sea, this is the Gulf of Lyon. Actually, we are counting the debris using fish stock assessment crews. For Europe, defining quotas for fishermen and so on, they organize international bottom trawl surveys. So they do have fish stock assessment every year with large ships and so on, large crews, and they are counting fish. And we did use these cruises that normally are dedicated to fish just to count litter. And so we do have the trends. It was started in 1994. Actually, these I present just only till 2009, but in fact we have every year data. Actually, we are coming to 2014, so we have 20 years of data. And the point is that the debris have been decreasing. The plastic are not decreasing, but the total amount of debris has been decreasing. So it's quite interesting. We know now that in 20 years, the plastic is quite the same. There is no change. But for other debris, they have been decreasing. So this is just an example of monitoring. So the problem is that marine litter are then degrading to microparticles. So one bag, maybe 100,000 small pieces of particles, nano-sized, very, very small. And we don't know about nano-sized. Actually, there is no information. There is no method available to assess directly at sea nanoparticles made of plastic. If somebody find that, for sure, this is a paper in Nature, I think, because this is a very important question. And so we do have data on beaches. So this is an example in our area, but also worldwide. There were plenty of experiments performed with different concentration. And the point is that litter, either large or small, are moving at the surface of the sea. So these are examples of transportation. For instance, we launched a buoy here, and it has been around to Spain, and then again back to Corsica, and then again to Spain, and then to Morocco, and then to Tunisia. It was in 9 months. This is the route that the litter took, So it means that, they are moving a lot. Again, there is a problem in terms of trans-border transportation. This is a good example of the litter coming from Italy, traveling to France, and then to Spain, and then to Morocco, and then Algeria, and then Tunisia. And so it means that litter, the problem is that if you launch somewhere, they could travel very long to another country. And so if one country takes measures, reduction measures, and wants to stop litter, he has to consider the litter coming from somewhere else, And so you can see that we regularly send to Spain. This is a problem. But when we send some in the Atlantic part, where we save also some from Spain, so it's something like more equilibrated. But Spain is sending them to Morocco, so. But it could be some problem, in terms of a law. And some country may complain because of that. You know, you remember the example of Lebanon, where they are pushing the litter, they are traveling, and they are going to other countries too. And for instance, in Corsica, we do have some litter coming from along Italy, and sometimes we do have some typical from Northern Africa with Arabic inscriptions, you know, or Arabic shoes and so on coming on our beaches. And because they are transported in. So, and this is an example of modeling where you, in one day, what was coming from the Arno River in Italy, this is day 2 and this is day 6, and you can see that they can dispatch and then transport. And the problem is that they can fix, I mean, some organisms may fix on this litter. So then it's quite interesting to understand how they behave at the surface of the world ocean. So this is an example. So in the Mediterranean Sea, it was published some years ago. But I mean, what is interesting in compiling all the data together, this is what did a scientist named Marcus Eriksen. He was able to locate, I mean, model, using different models, to evaluate where the debris will accumulate. As you can see, these are small particles in number. So it's a huge amount of, it's billions of small particles, and most of them will accumulate in convergence zones here, you know. And these are large macro debris. Macro particles, micro debris, large, you know. In number, it's not so much. So in terms of modeling, there is not so much. But if you consider the weight, in terms of weight, most important is with the large debris. So if you want to address the issue of effects, if it's related to number, micro particles will be very important. If you're considering chemicals or physical and entanglement and so on, then large debris will be more important. So the problem is that the people are more considering microplastics when in fact it could be large debris more important in terms of impacts than. So microplastics, small, are just important in terms of number. This is where they are important. So for instance, if one species, a bacteria, is settling on the microplastics, they could be transported very far, you know, and very fast, just because of the number. But if you consider chemicals, it's not microplastics that is important in terms of chemicals. So you can see the difference in terms of after degradation. Okay, so I've been modeling the fate in, I mean, after 30 years and trying to know where they will accumulate and so on. And I found that, I mean, the Bay of Bengal will be really affected. All the gyres will be very important. And also the Mediterranean Sea here, where we save a lot. So for us, it's quite important, even from Spain, you know. The quantities are actually the most important in the world in terms of microplastics and debris. This is the most affected area at the moment. So I will come back to this just to explain how it works. So you can see accumulation areas here, okay? So in fact, here at equator, do you have winds, alizé? Alizé in French, this is alizé, the name of the winds. Alizé, no? So they are pushing the waters to the west all the time. This is the same in the Pacific. The wind all the time are pushing the water. So there is a very important current, equatorial currents. So sometimes it could be inverted, but I mean, residual circulation, mean circulation always to the west. And so here on the west, or in the Pacific, at the middle, the water altitude is more important. There is more water in the west than in the east. And so because there is more water, the water must go. They cannot go to the sky, you know. So the water will leave, and the water will leave here to the north or along the coast. And in the Pacific will be the same. We'll go to the north, Kuroshio, this is the name of the current, or to Australia, Australian currents. And if I take the example of Atlantic here, the water will go from the Gulf to the north, and this is what we call the Gulf Stream, just because there is too much water in the Caribbean Sea, you know. Because of the wind pushing them to the west, there is too much water, then the water is leaving to the north, and then it becomes North Atlantic currents, and then there is part that will go to the north, and then the part that will come to the south, just to fill the hole, there is less water. And so it means that the water must go to fill this, deficit in terms of water. So at the end, because of, with the time, it's millions of meters cubed that are moving like that around an area in the center, and this is what we call geostrophic currents. So The point is that if you take, you know, lavabo, is that I don't know the name lavabo en espagnol. C'est une cuvette de lavabo. Dans les, you know, when you go to wash your hands, you know. Yeah, the sink. Yeah. Okay, yes, the sink. Yeah. Then you put water, you open, and you lavabo. Yeah, okay. And then you put some soap in, and then you open, and then it will go in the center. And this is exactly the same. Larger scale, but the behavior is the same. And so it means that everything that is floating will go there. And so the name of this convergence zone is Sargasso seas. I think Sargasso is a Spanish name, no? It's for algae, no? Portuguese. Sarga, varec in French, is a brown algae, you know, that are floating, yeah? And this is why the name has been given to this area, convergence zones. And so if the algae that are floating are going there, then the small turtles are going there, then the small anguilla, seavels, they are going there also, but plastics are also going there. And this is why they are accumulating there. But there is no islands, you know. Some people are talking about continents, you know, plastic continents and so on. It's completely false, you know. It's just more density, higher density, that's all. And in fact, it's less dense than in the Mediterranean Sea. Okay, so the problem is more important in the Mediterranean Sea than it is in the gyres. But you understand how it works, I mean, the physical and where they're accumulating. And then the general public is just considering that there is an island somewhere, you know, made of garbage, and it's completely false. Just higher densities only. Okay. So we are trying actually to evaluate transportation from one country to another one. So we do have modeling and so on. And we are trying to understand how it works. So this is just one example. So I'm working in Corsica, and this is how litter may be transported from Corsica to Italy in about 1 month. This is one example. We do have a lot of simulation and so on, different cases and so on, but it's quite clear that, I mean, in 1 month, the litter may transport it and go to another country directly. So then the problem is that degradation is very long. I was explaining that, I mean, we don't know about nanoparticles, but it could take hundreds of years for bottles to degrade. These are about 40, 50 years old on the deep, and especially in the deep because there is less oxygen and no light. So, I mean, bacteria are less active, and degradation is very less important there, and they may stay for, I mean, centuries and centuries there. We don't know. The only thing we can hope is that they will become like, you know, this kind of amphoras coming from Roman eras, you know, and take value with the time. That's the only point, you know. Okay, so about impacts of litter. The main one is entanglements. This is the most important impact that has been known. And so many cases, and some are very affected. I mean, turtles, this was in French Guiana. We do have overseas territories, France, and this was there. And also birds are really sometimes affected because they are coming on nets, you know. And if the nets are derelicted fishing gears, it means that they are ghost nets, you know, and they are still continuing to fish. Also, they are killing a lot of organisms, including fishes and so on. So this is an example of people working on new markers that could be interesting in terms of entanglements. The birds are picking all the debris to put them on their nets, you know. And so this is a study that has been performed in Brittany, and they found that the number of nests that are affected and the number of debris in each nest is depending on the location, and if it's close to urban areas, there will be more nests affected and more debris in. So most of the debris are, you know, this kind of things because long pieces, it looks like branches, you know, wood. And so they are using to build the nest. But in fact, they are litter, plastics and so on. And the problem is that the chicks, the small birds, they may entangle in this debris, you know, in pieces of nets and so on. And so we would like to use this kind of indicator to check for the pollution. And it seems to be working well. The only point is that you need to use a bird, a species that is living at sea. If you use a seagull, for instance, is feeding on land, so it's not marine pollution anymore, you know. So you must just restrict on some species that are really feeding at sea. And this one, the shag, is very interesting. So this is one example. Then the second type of impact is ingestion. So we do have a lot of examples with some species that are really affected. Birds, procellariforms, fulmar, for instance. This is an example. When they are flying at sea, they see some small particles, red, green, and so on. They will just ingest them, pick and then ingest them. And then at the end, you can see, this is a calculation that was made by the Dutch scientist, Jan Franeker. This is the mean value of plastics in fulmar from the North Sea. Actually, it's between 0.3 and 0.6 grams per fulmar. If you extrapolate to man, that will be something like in mean value, average value of liter ingested by man could be 60 grams. You know, you can imagine that it could be a long time that the people could have considered as a problem, you know. But for birds, they don't. It has been a long time before they consider it as a problem. But it means that for some species, they are really, really affected, and it's a lot of birds that have debris. Some fish are also very specifically affected because myctophids, for instance, because they come at the surface of the sea at night, and they are feeding on nutstone, and because of that, they are ingesting all the plastics. So the rate of ingestion in this species, myctophids, is more important. Normally, they are living in the bottom, you know, but they are coming at night, and they are ingesting. And also the turtles are really affected. It's something like we found turtles with 2.5 kilograms of plastics in the stomach, you know, with a lot of consequences. The point is that the turtles are considering plastic bags as jellyfishes. So each time they see something, they will go on it and fish. So we did have an experiment just to try to evaluate the risk in terms of the risk for plastics, for turtles to ingest plastics. So the turtles are ingesting various types of debris, but mainly plastics and plastic bags because they consider it as food. Okay? So the rate of ingestion coming from stranded turtles has been evaluated, calculated, and you can see that, for instance, Spain has about 80% of the turtles that are stranding on beaches have plastics in the stomach. 80%. It's really, really important, you know. And so it means not only it's good, interesting to consider it as an indicator, but also it's quite important in terms of, conservation for the population, because some are dying. They may keep for a long time without any problem. They may excrete, the debris, but there are some dead turtles because of the debris. Even if it's quite complicated for the diagnostic to say that it comes from, you know. But this is really a problem. So what we did have an experiment in France. It was 2011, 2012 by plane. It was the main purpose of the survey was to evaluate areas offshore to be protected. And so they wanted to have some information, and they surveyed birds, some fish, large sharks and so on, mammals and turtles, and also, by the way, they tried to assess the quantities of debris and so on. So it was a lot of. I will provide a process in the Mediterranean, then some results from the Bay of Biscay. So it was a specific plane, flying at low altitude, and we covered a lot of. Surface was very large. This is a sampling scheme, and you can see that we do have a lot of covering the whole areas and so on. And we found. For the Mediterranean Sea, for instance, we found that most of the loggerheads, Caretta, this is the main species in the Mediterranean and also in the Atlantic, was in summer. When it's in winter, they are probably going to the south, you know. And so then we counted, so these are turtles observed in winter and turtles observed in summer. And these are floating marine debris, the large debris, more than 20 centimeters, and in winter and in summer. And it was a bit more in summer, but more or less, the debris are circulating all the time in the area. And then we tried to merge both, and this is a probability of having turtles in the Mediterranean in summer, and this is the probability of having debris in this area. And then we merged both, and then we found an area where the turtles may encounter debris. This is where there is a risk for the turtles to find debris. And it seems that this is the case of circulation this summer, 2014. as an example. But I mean, compiling the data from NEMO models, we found that there is an accumulation area. This map is coming from currents, NEMO model, and gives the conversion. I mean, there is an index of conversions from currents. When they are concentrating, it's red. And when they are dispersing, it's blue. And this area is where the debris, because of the currents, are converging, you know. And so we can relate, and it seems that this is exactly the same area. So we are going deeper in this to understand exactly, but it seems that it's quite interesting to merge both types of data and indicate where the risks are more important. So you can see, for instance, in winter, we do have a lot of turtles around Corsica. Sometimes they are stranding. And if we just select fishing debris, nets, and these kind of things, then it's less debris counted by plane. But you can see that the area is a bit displaced. But we can check exactly where the risks are more important. So this is for the Bay of Biscay, for instance. The French part, we don't have the Vigo area, but I mean, it's not so far, you know. And you can see that if we consider just only Carreta, the risk will be in the southern part of the bay. And if you consider all species, then there is another species. This is a leatherback turtle, Dermochelis, you know, that is coming sometimes to the beach. And in that case, because there are more here, because most of them are coming with the Gulf Stream from the United States, then the risk will be located more in Brittany, you know. So we can check, you know, the difference and so on. We do have data for overseas territories in the Pacific and so on by plane, and we're trying to locate. So this is an example, you know, and you can merge and try to mix the data from debris with their impact on turtles. So it's not published yet. We still have to work on it, you know, it's just really starting. But we think that it will be possible with such kind of approach to have some good indication in terms of risk and impact. The point is that we will have regular survey in France for the MSFD, for the directive, and that will be every 6 years. So every 6 years we will be able to map the risk and so on. Okay, so then is there any impact on trophic chains? So the question is, people will say, so it's billions and billions of microplastics, so we may eat fish with some plastics in. So the point is that we know that using polystyrenes that have been with a dye, you know, a fluorescent dye, it's very clear that they remain in the gut, you can see. And so there is no translocation. There was a paper in 2008, young English, publishing about translocation of microplastics, particles inside the body, you know. But it's not clear about, and most of the experiments are indicating now that, I mean, they are transiting through the gut and are extracted. So it means that at each step of the trophic chain, the debris normally will be extracted in some hours for the copepod, just a question of 2 or 3 hours, of days for mussels. This is mussels here, and these are mussels. So normally they will not ingest. So you will find some papers with a lot of microplastics in the gut and so on. It's possible, I think, that they ingest because they are mussels are filtrating, but normally they will not keep them. So in terms of impact, transfer, and so on, the contaminants that are on the plastics may be translocated in the tissue, absorbed to the tissue, and then, to the trophic chain and so on. But for the particles themselves, physically, it seems to be impossible. So if you find one in large fish, it could be coming from the prey, but I mean, the chance is very low, you know. And also, we do have some question about the point. I mean, plastics are all at the surface. And it's quite complicated to understand how a mussel that is in the water or a fish that is in the water will ingest a debris, a small particle that is at the surface. So we do have some question remaining, even if there are some experiments and paper indicating that there is some microplastics in the guts of some fishes and so on. So there is a real question there. It's not clear. We do have some experiment. The Greek, for instance, they had an experiment with 150 fish. They didn't find any plastic particle. And sometimes, some paper, they indicate, 20% of the fish with it. So it's not clear. What we know also is that there is a large, important risk of contamination. If you take pure water, you count with this normal process, extraction and so on, then microscope and so on. This is a control. Then you may have a lot of fibers coming from closest, you know. So it's quite important when analyzing. We do have this problem with microplastics. Then we do have another problem. This is that the species are settling on litter. So this example, this was in Greece, Thessaloniki. It was a piece of polyethylene. We cannot see it anymore. This one is not, I mean, it's not really interesting. It's not related to the point. But I mean, some animals are able to transfer from one continent to another one for very long distance too. The best example is the one from tsunami in Japan. It was 5 million tons of debris that went to the sea. Most of them have been sinking to the bottom, but some have been traveling from Japan to Canada. And we discussed with some Canadian scientists, and they found that it was 120 new species for Canada that came just after the tsunami in 6 months. 6 months after, it was already 120 new species coming too. So it's very important, you know. It's not something like an anecdote, you know. It's really, really important. And actually, they are starting a very important program on this because they don't know exactly. Some have been sinking, probably. And it was just only dedicated to the macrofauna, not bacteria, unicellular, and so on. They didn't check for it. Nobody has been working on this. So it could be hundreds and hundreds of new species coming, and they don't know, absolutely don't know, I mean, what will be the real impact in terms of biodiversity and ecosystems and so on. So this is one of the main risks. And this is quite important. This is where the microplastics are very important because, you know, if a species is fixing on a boat, on a ship, I mean, at sea, the ship is very fast, will be 10 knots, 15 knots, and so on. So the animals cannot fix on. And so they will settle in a harbor. And when the ship is leaving, it will go straight on to another harbor. So the transportation of invasive species will be from one place to another place. But with microplastics, billions of microplastics, far more than any ship, I mean, they are going everywhere and very slowly. So when they are on the way, I mean, some new species can settle, and then they can be transported. So the risk of dispersion is more important than with the ships, for instance, you know, or ballast and so on. And it's open. They found some very recently, so we found some algae, for instance. We do have in the Mediterranean, the laboratory of Angers, the University d'Angers. They are working on a foraminifera that is settling. And normally it's living on the bottom, and then you have larval stage of days only. And when it's more than 80 degrees, the larval stage is blooming, you know. I mean, the species is blooming at the surface, and they are settling on plastics. So they are colonizing, you know, the plankton, where normally they must live on the bottom. So in terms of biology, it's quite interesting. And we have plenty of examples like that, and we don't know about transportation. These are algae, for instance. We found them in the Mediterranean. And, okay. Then beside transportation, we do have also social problems. I shot that photos myself. It was in Gabon. I was working on the co-toxicology of, cuttings from oil platforms and so on. And coming back to the airport, we found just by the sea, it was like a totem they built with all the debris and so on. So it may be possible that the behavior of the people has been changed with the presence of debris. There will be one expo tonight, I think, no, in Vigo. Yes, and with art done with, so you can see that the people are just using this kind of situation for. And also one of the important impacts we have is impact on fishermen. The cost of cleaning the nets, for instance, I mean, to selecting fish from debris and so on, in the Mediterranean could be a lot of time lost just because of that. So there is a real impact on fisheries, and also socially, I mean, the cost of cleaning, for instance, for tourists and so on, is very important. And they know, actually, there was one study, and they know that if you increase the quantity of litter by 20%, for instance, you will decrease the people coming by 5%. So they begin to know exactly the relations between the quantity and debris and how the people will come or not, you know. It's just starting this kind of questions. So we do have some effect on human health. I mean, mainly accidents on the beaches. I mean, the children and so on, syringes sometimes and so on, pills and chemicals and so on. But Ireland, an NGO, was explaining to us that there are 2 cases of young guys that were entangled in nets, lost nets, and were killed because of that, you know. So it seems that there is a risk also for the people, to be killed because of the debris at sea. We do have also some impact on navigation and so on. And again, the point we have been discussing about the transportation of species that are fixing on, but also one paper was published at the end of last year, and they found that the bacteria from the family of, these are algae, but bacteria from the family of Vibrio, like cholera and so on. And I'm not saying that cholera is transported by plastic, but I mean the same bacteria from the same family are able to be maybe transported by litter. And there is one paper where they tested pathogen for fish, so it could be important for aquaculture, for instance. And this pathogen may fix on any kind of debris, hook, or iron, for instance, metals, but also plastics and so on. So there is a risk also that the plastic may transport pathogen. And in case of area which we have a lot of, aquaculture and so on, if there is a virus coming, for instance, it could be a vector to increase the transportation of the virus at sea. So this is one question in terms of risk. And we think that it could be very important because, the cost could be very important behind, and also maybe because of health. Okay, so there is not so many solutions. A lot of, this is the case of Adour River. The case of Adour River here. They have a barrage just to retain. After the map, I show about the Adour River in Basque Country. They put a barrage on the river just to retain. They are reusing the wood from and taking back to discharge all the plastics. So it's quite interesting because there was a lot of coming. Then cleaning directly, but that will take time, and it's not really a solution. Then you have this kind of initiative. They put some collectors on the beaches. It works very well in France. It's really efficient, really, really efficient. Then collecting, there are actually some operations. Some are funded by European Commission and DG Mar. West Free Ocean, for instance, is an example. They are collecting. I think that in some areas could be interesting. The most interesting will be to collect fishing nets that have been lost and are located on the bottom because they do have a value. And for instance, the Baltic Sea, some part of the Baltic Sea, they do have a lot. Northern Adriatic, for instance, they do have a lot. And the Italian from CNR, they dotted individually all the nets, and actually they are collecting them and sending them to a company that is in Slovenia that is crafting some clothes with nets, and it works very well. They are reusing all the nets from aquaculture, for instance, and they are really making a lot of money with that. That's very strange. Actually, they are saving from China also the nets, because the people that are doing some aquaculture, they have to change regularly. Every 5-6 years, they must change the nets. And so they are collecting all these nets, but also from the bottom, and it seems to be yieldy. they're making money with that. Then you have also cleaning, Basque Country in France, Côte d'Azur. They spend millions and millions of euros every year, because the choice is very clear. It's either the tourist or the debris, and they choose the tourist for sure. Okay, so they have to clean or the tourists will not come. That's the point. And also asking the people, the young to clean. It's often you will see on newspapers and so on initiative, the people are coming, they are cleaning one beach and so on. So it's good, for socially it's nice. But we just are asking to the young to do something that we don't do naturally. So I think that is not really a good solution. So prevention is probably better. So there are a lot of convention agreements and so on. It's not, it's quite complicated, because we always recommending, but then to do things is more complicated. So MARPOL is a restriction on garbage from the ships, for instance. London and Bâle, some dangerous garbage. Honolulu strategy is an agreement on law. Berlin Conference has listed all the reduction measures to be implemented within the MSFD. This is the Marine Strategy Framework Directive that is for the first time monitoring marine litter, and this is very good action because the budgets are quite consequent. And we do have, some OSPA, MedPol is the one, and I will finish with OSPA that will meet from tomorrow. There is a specific meeting in Vigo, and where all the people from Northeast Atlantic will meet to address the issue of marine litter and how they will consider the marine strategy and the monitoring and so on, and then reduction measures. So it seems that politically the people are starting. There is a lot of interest from, all politicians. The Berlin Conference, for instance, there were 3 ministers, and the data have been presented to John Kerry, for instance, in the US, because United States would like to act on this. All institutions, CMS for migratory species, for instance, MedPol, or all UNEP activities and so on, they are actually considering litter. It seems that for the decades to come, there will be a strong, interest and support to do something on it. So it's, in terms of science, quite important because actually, if you see the number of papers that were published, we started in 1992 at Ifremer. It was 1 or 2 papers a year in Europe, maybe 5 to 10, and then actually it's more something like 300, 400 every year, coming. So there is a lot of interest. Even now, even the very important journals, Nature, Science, for instance, they are considering papers actually on this topic. So it seems that there is really a good interest also for science. Okay, so the marine strategy, we do have to consider this descriptor as the same level than the other, so it's quite important, for instance. We do have 4 indicators on beaches at sea, microparticles, and in the future nano, and ingested litter. We do have a group. Jesus, Dr. Gago is part of it, together with 60 experts from different countries. And we are trying to support ministries to implement, so providing technical recommendation. We provide also guidance and monitoring. Actually, we do have report in progress about sources and so on, and that will help the countries to take measures to know exactly where they're coming from. At the end, we would like to map the sources, for instance, exactly what are the most important points to be considered and so on. And so we did have a lot of consideration what to do. We plan to have in the future, that will take time, probably a model of transportation at the European scale to know exactly where they are coming from and where they are going to. Then understand how, better understand harm. Transport of invasive species, from my opinion, this is one of the main important points. And then, new indicators and so on, and different kind of impacts and so on. At the end, I just retain some images. The point is that I think it is important to consider that when you consider source, for instance, most of the litter, main part of litter is coming from the people. If you consider, for instance, industry, you check for microplastics at sea in the North Sea, in the guts of fish, of birds. It's just only 10% that are directly from industry, the losses. 90% are coming from bags and bottles. So it means from the people. And so it's quite complicated in terms of education. If you want to change the people, it will take a long time. And so at the end, you can see the people. They are able to, it's really incredible, You can see some, tombs directly, like, normal, bottles at the sea and so on, It was on the beach in Le Havre. And you can see everywhere. And even, this is it says if you want a clean area, And they said, please take your garbage with you, And this is what the people are just throwing away. So this is just to illustrate that the problem is most of the time coming from the people themselves, people itself, more than, any, rules, industrial or action and so on. Every day the people are just throwing and throwing. And it's quite complicated to act on diffuse sources like that. Okay, before I close, I would like to show you a movie. Okay, this was taken by submersibles, our Ifremer. So this one, it was 1,000 meters, 20 kilometers from the coast in the Mediterranean Sea. So I was in the submarine. I've been 8 times down to the, and you can see when you come to the bottom, you're expecting something very exotic, You are a treasure or something like that, But in fact, you're just finding bottles and so on. And anytime there is a rock, a hole, and so on, it's surrounded by bottles and plastics and so on. Anytime, everywhere in the Mediterranean. If you see on the abyssal plain, for instance, it's less. You will just see sometimes, But each time there is a hole, a hole or a stone, a rock and so on, around there you will find plenty of. And this is 1,000 meters. And it's the same, more deep and less deep everywhere. And it was 20 kilometers from the coast, So it's something that's really amazing, You go and you're just expecting for new species something very strange. And in fact, just garbage on the bottom. Okay. So thank you. Yeah. part of these debris. Actually, we are trying to consider sources. It's quite complicated to understand exactly where they are coming from. The point with plastic debris is that the sources are really diffuse. So we know that some are coming from rivers. So this is the Seine River in France. And you can see on the side, you know, the litters are accumulating. And this was a count of, you know, they are used clean ears. It's a count for just only 100 meters along the Seine River. So if you look precisely, just, take the stones out and suddenly collect, and then you will find plenty of, and it's really a huge problem. So sources are also, sometimes they are coming from marine activities. This is an example that comes from a European project, Lost Cont. And these are the containers that were lost, in the Bay of Biscay. Okay. All the containers that were lost in the Bay of Biscay. And you can see that because of the traffic lanes here and the entrance of the channels, this is, most often where the ships are losing their containers. It has been considered it's about 10,000 containers lost in the world every year. And one container is 20 tons. So it's really important because if you consider microplastics, for instance, the total amount will be something like 30,000 tons at the surface of the sea. If you consider containers, for instance, in terms of quantity, it could be more than any gyre or conventional joints in the ocean and so on. So lost containers is a very important source. Then you have some discharge. This one is in the Mediterranean in Lebanon, and it's directly by the sea, and the bulldog of debris is coming, litter is coming from land, except in some areas, for instance, southern North Sea, because of traffic. It has been inverted, so it's 80% is coming from marine activities at sea, traffic mainly. So most of the time, it's just coming from the land with diffuse sources, and we don't know exactly at the moment where they are going. So this is really a problem. So then after, what will be the fate of plastics? So sometimes it could be 100% for floating debris, for instance, but most of them will go on beaches. This is an example in Libya. We had a cruise in 2009, before the war, and we found some beaches with really lots of plastics accumulating. This is in the northern part of France, Atlantic, and this is a specific problem in some areas, Mediterranean, but also in some other countries, of cigarette butts. And we were told that by English scientists, MCS, they will come tomorrow at the meeting there, that because there were some restriction on smoking, it's actually forbidden in public areas and so on to smoke. And in some offices, the people are used to go outside the buildings and offices and just smoke outside. And then they are throwing away, the butts away. And then because of the rain and so on, it comes to the wild and sometimes to the sea. And just because of that, because of restrictions in the last 3 years, the number of butts have been increased by more than 20% in Ireland, for instance, in beaches. So you can see in terms of health, it's quite interesting to restrict the use, but in terms of environment, it could be, adverse effect. So litter may also float. So this is an example count by an NGO in the Mediterranean Sea, where actually we are working. And so what is interesting there is that we can see that we found them, MSFD, Marine Strategy Framework Directive. It has become something like very important. At the same level, actually, in terms of policies and management, at the same level than biodiversity or chemical contamination, eutrophication, and so on. So in terms of policies, it's very important. And also in terms of social problem, it is a really important social problem. And so the politicians are following this topic, and it seems that they will take some reduction measures very soon. So the point with marine litter is that it's about 4 million tons of garbage every year in the world. So for Europe only, it's half ton every year from each individual. The total amount of plastics is around 290 million tons every year, actually, and is increasing regularly. So it's a lot of plastics that are being crafted. And it's about 6 million tons. This comes from the National Academy of Science. 6 million tons of debris from ships every year that are discarded. And we evaluated the concentration of microparticles that are coming from the degradation of plastics. to more than 100,000 in the Mediterranean Sea, and the Mediterranean Sea is one of the most affected in the world in terms of plastics and microplastics. So marine litter is very diverse. It's a lot of types of debris. I mean, you can see from, plastic is the main important, caps, lids, and so on, but also bottles and so on. But any kind of debris, you will find them. We do have a lot of stories, strange stories. A Wonderbra found them in trousers and so on, cars, planes found in the bottom of the sea and so on. But what we have to retain to know is that plastic is most important. Merci. Merci. Thank you, Jesus. Thank you. Welcome. Well, welcome to you. I'm really happy to be here in Vigo. This is the first time in my life. And it's something like I was dreaming of, a long time ago. And so I'm really happy. And so it's, even if we are a small committee, I'm a bit impressed. And so I'm working at Ifremer in Corsica, a small island in the south of France. And I was in Nantes some years ago, and also Ricardo was working with us at that time. And it started a long, very good career and on ecotoxicology, and then we switched to marine litter. So I will try to give some explanation about, I will try to make it very informal so that, the people are really relaxed and can ask during the talk if you want some more explanation. Don't hesitate for that, please. So usually the sea is something, the feeling about the sea is something like we consider it as exotic, or there is something, traveling, islands somewhere, blues, lagoons, and this kind of things. Sometimes power, large waves, and so on. And besides, there are some economic activities. Fishing, for instance, aquaculture, transportation, and so on. And the problem is that beside the sea, we do have the land, and from the land are coming a lot of pollution. So the most some are well understood actually, such as oil pollution and so on. You did have some bad experiments there in Vigo, and also metal contamination and so on, radioisotope and so on. And an emerging field is dedicated to marine litter that was starting, in fact, a long time ago, but just from a small community, just some scientists who are considering this problem. And it seems that because of DG Environment, European Commission considered that as a main problem in 2008 when it launched the European directive. Others are coming and just pushing all the debris at the sea. And then the debris are starting to circulate from Lebanon to Syria, Turkey, Greece, and so on, and then to other countries. And they're just pushing the litter at sea directly, They don't care about, And so this is an example of lost consciousness, and these are what we call mermaid tears. It means pellets made of plastic. If you want to give a form, a shape to plastic, you have to warm. But if you want to warm a large piece of plastics, it will cost a lot of energy. And so instead of having transportation of large pieces of plastic, they are transporting in just small pellets. It's more easy to warm them and to shape them. And this is the reason industry is just using pellets. And sometimes they're losing some. There were some accidents in Hong Kong 3 years ago, for instance, and regularly on beach you can find this kind of small pellets. These are colored, but most often they are white. And the name is mermaid tears. It's a very nice name. Mermaid tears, it was a name given to small pieces of glass in Greece long time ago, and it has become just pieces of plastics, actually. Then maritime activities, aquaculture and so on, especially in Vigo, for instance, is a source. Some countries are really affected. Korea, we went together in Korea 2 weeks ago, and they do have a really big problem with polystyrene coming from aquaculture. Also Chile, southern Chile, because of cultivation of salmon and so on. So these could be very important source of marine litter too. Tourism also is quite important in terms of inputs. It could be the main part of litter on the beaches in some areas, especially, for instance, in the Mediterranean. And so, more or less, we know now that it's about 80% is coming